So for number 5, you have x minus 2 over x plus 3, x minus 2. Okay, now again, go ahead, think about restrictions. X can't be -3 and 2. And what you can see right away is that the x minus 2 could be canceled out. So what would you graph? You graph 1 over x plus 3. But x cannot equal to 2. I mean, it cannot be -3 because of the vertical asymptote, but because we cross out the x minus 2, we'll graph this with the understanding that x cannot be 2. Can you just do it mentally? If x is 2, what's the y value? 1 over 5. All right? Because when you have x equals to 2, yes? Well, -3 is our vertical asymptote. Okay? X equals to -3, it's our vertical asymptote because that will send the denominator equal to 0. All right. Now, what about the horizontal asymptote? Y is equal to 0 because when x becomes infinitely large, x plus 3 is just x. 1 over infinity is just practically 0. And then we will look at the x-intercept, which actually there'll be no x-intercept because the numerator can't be 0. The numerator is 1, so this fraction can never be 0. And for the y-intercept, when x is 0, the y value is 1/3 because when you put in 0 for x, you just have 1 over 3. So 0, 1/3. That's the y-intercept. Where's our hole? Our hole is right here. So very close to the x-axis. So that's how you draw your right-hand side of the graph. Okay. And since there is no square of any sort in the denominator, so there will be a sign change. So the graph would head to the opposite direction as a result. If you need any kind of confirmation, you can simply go ahead and think about what's f of -10. F of -10 is 1 over -10 plus 3, which is 1 over -7. So somewhere on the negative side. So that's how you know where the hole is. Okay, whenever you cancel something out, that's a huge signal that there is a hole because you still cannot equal to that particular x value. So you would draw the hole with an open circle. Okay.